Stars and bars. Yeah! We are learning about the stars and bars counting technique today. So get ready to learn. You may find yourself in a shotgun shack, or you may find yourself trying to figure out how many ways to choose 12 donuts from chocolate, glazed, and powdered. If you have to choose at least one, and who doesn't have to make this decision every weekend? You may also be asking yourself, how do you give 12 identical chocolate chip cookies to 3 kids if you have to give at least one to each? Because that's mean to give somebody none. Or you may be like, how many positive integer solutions are to the equation a plus b plus c equals 12? Well, believe it or not, all 3 of these questions are absolutely identical. They all break down to how many ways there to add a plus b plus c to equal 12. They're all the same exact thing, and we solved them using stars and bars. So let's do it. You got a plus b plus c equals 5. We're going to simplify it. Not going to do 12 yet. We're going to do 5 because 5 is easier to work with. So different question, different problem, but same technique, and then we'll go back to the one that involves 12. So if they have to equal 5, let's look at the different possibilities. You've got 5 stars. Each star is going to represent one thing. Like it equals like, each one is like one value, like one unit or one cookie or one donut. And we're going to break these stars, cookies, donuts into 3 groups. So to do that, we need to put in dividers, which we call bars. And how many bars do we need? Well, we only need 2 bars for 3 groups, because once we put a bar in between the first, you're going to have one group, and then a bar, and then the next group, and then a bar, and then the third group. All right, and so we have 4 different options you can see between the 5 stars, and we need to put in 2 bars. So let's see what that would look like. So you got 5 stars. You could put a bar in the first space and the second space. So that would basically mean like A is 1, B is 1, and C is 3. Or you have like 1 chocolate donut and 1 glazed donut and 3 powdered donuts if you were only doing 5 donuts. Or you could do the first and then the third gap. So then that ends up being 1 star, 1, 2, and 2. So like A is 1, B is 2, and C is 2. And you could keep going through, and you could look at all the different iterations for when you have a bar in the first. And then we're done with the ones with the bar in the first gap, and then bar in the second. And there's that as a possibility, 2, 1, 2, and then there's 2, 2, 1, and then there's 3, 1, 1. And those are all 6 possibilities. Now, hopefully you know a little bit of something about combinations. If you don't know about combinations, I'm going to make a video on it, so watch the video. But combinations are super helpful in doing the math, so you don't have to do all the possibilities, write them all out every single time. So this is basically, we have 4 different spaces, we're choosing 2. So it's 4 choose 2, and that is it. 4 choose 2, which is 4 times 3 over 2 times 1, which equals 6. So let's go back to the problem involving 12. So again, if you have 12, think about it as having 12 stars. You don't have to write all 12 stars out though, but it's good to visualize it. And you visualize it, and then you think, how many spaces are there between the 12 stars? 11. 12 stars, 11 spaces. It's always one less space than the number of stars. And we're trying to break it up into 3 groups. So how many dividers do we need? 2. So there's our 11 spaces. 2 different bars, so like 1 bar there, maybe 1 bar there. So that would be like A is 3 and B is 3 and C is 6. That's one possibility. We want all the possibilities. So 11 spaces, choose 2 bars. 11 choose 2. All right, 11 choose 2 is 11. 10 over 2 times 1 is 55. You don't want to write out all 55, but there are 55 different ways for you to make your donut selection. So the math behind it, though, or the formula for this is basically n minus 1. So however many things you're choosing from, whether it's numbers, all right, or it is donuts, or it's cookies, or it's dollars, or whatever. N minus one. That's how many spaces you have, and then however many things you're breaking it up into, subtract one from that. That's what you're choosing. Now, you might get a problem that makes things a little trickier because you could have zero. All right. Oftentimes you'll see these problems where zeros, they'll say non-negative integers too. Non-negative integers means all the positive integers, 1, 2, 3, 4, 5, plus zero. So if they can equal zero, this becomes a trickier problem, but you can still use stars and bars. I've seen lots of different techniques, but the one I'm about to show you is my personal favorite because it uses what we just learned. We just do a little transformation and we can do the exact same technique. So you don't have to learn something totally new. And I feel like it's just very logical. So here's what you do. Add 1 to A, and add 1 to B, and add 1 to C, and add 1 to D. And so if you're adding 4 on one side, you have to add 4 on the other. So you always add 1 to each of the variables that you're working with. So in this case, we're going to add 4 to both sides, all right? And so that basically just breaks it down to a brand new equation. I can replace A plus 1 with W, B plus 1 with X, C plus 1 Y, and Z, and that equals 14. Now that right there is the same as the stars and bars that we were already working with, because now if we're taking everything has to be 0 or above and we add 1 to it, now everything has to be 1 or above. So if we look at how many different possibilities we have for that bottom equation, we've got the same as for the top equation. It's the same exact thing. So basically now you have like 14 stars, all right, and you're going to choose because we have four things we need to break it up to. We're going to put in 3 bars, so it's going to be 13. Choose 3, and then if you want to visualize it, think about your 14 stars. You put your 3 bars in, and then if you want to really make it look like the A plus B plus C plus D equals 10, just take 1 star out of each one after you've already done that. And then because that's how you can get a 0, because if one of them had 1 star, now it's down to 0. So it works. So it's beautiful. So it's basically 13, choose 3, because again, we're subtracting 1 from our 14, we're subtracting 1 from our 4. And 13, choose 3 is 286 if you want to do the math mentally. But you can also use a calculator. So you just, or if you've got an Nspire, you do NCR parentheses 13 comma 3, you get your 286. So there's 286 ways of solving for that. And let me leave you with this. A star walks into a bar. Lights the whole place up. Bartender says, "Are you kidding me?" The star says, "No, I'm serious." Get it? Sirius is the brightest star in the night sky. Crickets. Maybe next time. All right, bye.